Okay, this is just a very quick whistle-stop tour around how to perform a peptide samples t-test in Excel. So, first and foremost, don't worry if you're not able to access SPSS if you don't already have the software. With your sort of basic statistical tests like a t-test and others in that vein, um, they you will get the same results in Excel as you would SPSS. If you were to try and perform an ANOVA, let's say, in Excel, which is where you would have three different conditions or more, you the output of your stats test would tell you if there was a difference between your data, but it wouldn't tell you where exactly. So it could be between condition 1 and condition 2, could be between condition 1 and 3, could be between 2 and 3, but it wouldn't tell you. So I often think I don't know why they put ANOVA software or the ability to calculate an ANOVA in Excel if you can't know where the difference is. But t-test, you do it here, you do it in SPSS, it'll be the same. And all you have to do is a series of repeated measures t-tests. So it shouldn't take too long. Right, so we have three different sets of data here for the hip, knee and ankle, and I haven't specified what they are because obviously that might vary based on what you decide to look at in your data. But let's assume this is kinematic data, obviously. I haven't included any ground reaction force data, but you would analyse that in exactly the same way. And I've got condition 1, condition 2, condition 1, condition 2, condition 1, condition 2. So condition 1 would be barefoot, and condition 2 would be shod. Okay, so that's what we refer to when we say conditions. So each number in these cells represents a participant's average of each of the trials that you have performed. So for example, participant 1. Okay. Let's say when they were running across the force plate barefoot, the hip kinematic data came out on the first trial, so trial 1, trial 2, trial 3, as, I don't know, 43, 42, 44. All you would do is average these three together, so add them together and divide by how many there are. If you want to speed that up in Excel, you can type in equals average, open brackets, select the data, close brackets, and there you go. And that value is the same as that value there, okay? They are the same, they should go there. Okay, there and there. Okay, so each piece of data across, basically each row represents each participant's data. So this would be participant 1's data here, this is participant 2, this is participant 3, you get the idea. So it's a repeated measures experiment. Same participants performed each of your two conditions, barefoot and shod. So, onto the actual stats testing. You click on the data tab up here and you should see an option that says data analysis. If you don't, you go over to file, options, where are we? Add-ins, and these two software packages here, or these add-ins, Analysis Toolpak and Analysis Toolpak VBA, will be down here in the inactive application add-ins. You have to click on each one and click on go and then OK. So click on one, hold down control or hold down shift. Oh no, it doesn't let you do that anymore. Oh well, you have to do them one at a time. click on one, click go, and it will then shift up to here in the active application add-in. Click on the other one, and then it will click go, and it will also move up into the active application add-in. Then click OK, and you will see this tab here, this data analysis tab. So we click on data analysis, and we've got a few basic statistical tests we can do, but again, it's fine. As I said, the sort of test that you get, or the output of your statistical test in Excel, if you're just doing a t-test, will be the same as SPSS. The only thing is, in Excel, you could select all of your data for the hip, knee and ankle at once, and it would analyse them separately, but you'd only have to do one t-test, if that makes sense, whereas you're going to have to analyse each data set individually. So you're going to have to do the hip, the knee, the ankle, and then any ground reaction forces individually. But excuse me, I've got a little bit of a drink, got a sore throat from all these online lectures. So let me just clear this. I just did a trial run to make sure it worked. Okay, so you will then have this window here, and for variable range 1, we click in this cell and select our first column of data that we want to analyze. We include the label, in this case barefoot, because this will just help you avoid confusion if you come back and look at your data and don't know what it means. I always include the labels here. You then select variable range 2 in your t-test window, and again drag and drop from SHOD all the way down to your last cell, and that's your data selected. We then click on labels to let the software know that the first cell in each column is a label and should not be included in the analysis. We're not going to predict what the mean was. This output options will probably be on new worksheet. We don't want it on a new worksheet. We want to select the output range. You then have to click in this cell. This used to frustrate me because when I was learning how to do this some time ago, you'd click on output range and it doesn't automatically select this cell, and then I would just assume that this cell would be selected, and I couldn't ever get it to work, and it would drive me mad. So you have to click output range and then select the cell, and make sure your cursor is flashing in there. A young Professor Tejan at sixth form was enraged by this. Click on the cell that you want your data to be displayed in, and that's it. You're good to go. Just click OK, and there we go. You have your pair sample t-test. I would also at the top just write what this is for. So let's say hip, just so you don't forget that either. So there is lots of data here that we think, do I need all this? No, you don't. So let's go through what you do and don't need. You most definitely need the mean values. You only need to go to one decimal place. So this 40.875, we would just round up to 40.9. Okay, you don't need the variance, you don't need to know the number of observations, you can just count the number of observations. Pearson correlation isn't relevant to what you're doing. You haven't hypothesized a mean. The degrees of freedom aren't relevant, nor is the t-stat in this instance. Excuse me, sorry. We simply want to know these values here. In fact, we don't even need the critical t. There we are. Now, both of these are significant. They're both less than 0.05, so this is your p-value. Okay. Each test is slightly different. A one-tailed test is simply predicting, or the software predicts that one value will be greater than another, the two-tailed test suggests that one value could be lesser or greater than another. So in statistics, we go with the two-tailed test because it's more accurate. But if this isn't significant, and this is, some perhaps not so scrupulous statisticians will go, oh well, this is significant. Let's just report this. But it's not as meaningful. So really, we want this. So here, here and here. This is all we need. Actually, no, I take that back. That is not all you need. You've got the average. You've got the p-value there. Again, that can just go to, that will have to go to 2 decimal places. But you also need to work out the standard deviation, which I believe I showed you in a previous video, but let's just do it here. So underneath each column, you type in stdev dot p, not s, open brackets, select your data, don't include the label, close brackets, hit enter, and there is your standard deviation now. We don't want it reported that high, so so we've just taken that down to 1 decimal place. Now what we can do, by the wonder of Excel, so this is your standard deviation here, is select the cell that we've typed that into, move our cursor to the bottom right hand side of the cell, so you see our cursor changes shape into a slightly smaller crosshair, and we drag and drop all the way to the far right hand side, and it will perform the same calculation for each column of data. Obviously where there is no data, it's got a bit confused, so we can just delete that. So these values are the standard deviation. What colour should we go for? We'll go for the same red, yellow rather, because we need them. Okay, so this is the standard deviation. Okay, I'll show you one more time for the knee, how to do the test, and then we'll leave it there, I think. So, data analysis, two-tailed t-test, t-test paired for 2 samples for mean, so paired t-test. You have to delete what's in the cells currently, because that's the test remembers the previous data you analysed, so you need to clear those cells. Variable range 1 will now be here, don't include the standard deviation. Variable range 2 be here. Labels, output range, pick somewhere to put it, that'll do. Bosh. Yeah. And again, all we need to know is the basics. As I said, get rid of that. Get rid of them. There you go, and both hugely significant because I engineered them to be that way. So there we go. I hope that helps. You're probably now going to wonder, how do I report the data? So let's clear that one up. You do this in Word, obviously, or you can do this in Excel and then transport it into Word, but that tables in Word tend to be a bit iffy. The software struggles with it for some reason. It can be a bit of a nightmare. But personally, what I would do is have a few columns of data. I'm just making these a bit bigger.